Hi everybody. This is a short vlog to talk about adjusting the elevation on the differential level loop that we ran in class back before spring break. The documents that you'll need to go through this procedure with me are here in lab number 5, which we did on February 25th, the differential level loop exercise, plus your field book with your notes from that day, and then plus the document that you'll find on our Moodle page down at the bottom of this first section after spring break. That document is right here, the field notes for the vodcast on adjusting the level loop. So I have recopied this. I've borrowed this document from one of your classmates and taken the data from one of the groups. This group had very good data. The misclosure, as you can see, is just 0.02 feet, 2/100ths of a foot. The other group, as I recall, the data was not as close, and if we had done this in real life, we would have had to reshoot the second loop, the one with the larger misclosure, but we're going to just adjust it to learn the procedure at this point. So basically what you would have right now in your field notebook would be the data that I have and the words that I have written in black, except for the elevation of the flagpole from the data. So basically, you have a series of back sights and a series of forward sights, and then you have summed them up to see how close they are. Now, in a perfect world, they would be identical, but they almost never are. If they are not identical, what that implies is that there's a slight error in the data that you've collected, because we know that in real life that the benchmark, either the flagpole or the fire hydrant, didn't actually move during the course of our time. So what we have to do is to decide where we're going to add or subtract those adjustments. Now here, the back sights, 17.67, are larger than the forward sights, 17.65. So that means that my pluses, because the back sights are pluses, are larger than my minuses. So that means that I have too much, there's an excess, okay? So what that means is I'm going to have to subtract in order to get rid of that excess. If it was the opposite, if the forward sights was greater, I would have to add to make it come out. But the big deal is that whatever the elevation of the flagpole is at the beginning, it has to be the same as the adjusted elevation of the flagpole at the end. Or if you start from the fire hydrant, same thing. But here, I've looked up some ephemeris data, and I found that the elevation from the flagpole is 4395.21 feet, and that would be above mean sea level. So I write that piece of data in here. Then what I do, the HI column is the first column I'm going to calculate, and the HI is the height of the instrument. So basically, if I take the known elevation of the flagpole and add the first back sight, I get the height of the instrument at the first setup. Then, to get the elevation of the turning point, or the temporary point, I would take the height of the instrument and subtract this forward sight. So then, continuing on this pattern, to get this number, I take the uncorrected elevation, and I add the back sight, give me the second height of the instrument, subtract the second forward sight, and I get the elevation of the fire hydrant. Now that value is, once again, uncorrected. To finish off this pattern then, I would take the back sight from that point and add it to get the height of the instrument, the forward sight from that point, and subtract it to get the uncorrected elevation. Now what I see is that the flagpole started out at 4395.21, ended up in an uncorrected way at 4395.23, meaning that it's 2/100ths too high. And I know that didn't happen. What we have to do is to reconcile this number with this number, in other words, make it exactly the same. So that means, just like I had predicted, I have a misclosure of 0.02 feet, 2/100ths of a foot, and I'm too high. So I need to subtract off 1/100th on a couple of these measurements. Now if this were larger, or if I had some insight, I may have a more sophisticated way of distributing that error. But when I only have 2/100ths and I have 3 shots, it kind of fits that 2 of those shots are each going to lose 1/100th of a foot. So that's exactly what I do. So I correct the first, the elevation of the temporary point, by subtracting off 1/100th. And then I correct the elevation of the fire hydrant by subtracting off 2 100ths. Now, this is 2 100ths cumulative, so I've subtracted off 1 100th here and 1 100th between the temporary point and the fire hydrant for a total of 2 100ths. That brings me to the elevation of the flagpole, which then I don't have to subtract anything from. I just have that cumulative 2 100ths of a foot, and that gives me an adjusted elevation that is identical to the actual elevation of the flagpole. So you can use this as your example. You have my work, and you also have from your notes, you have the lab procedure that shows you how to do this as well. And on our Moodle page, then, get rid of this, come over here, you'll see that we have the Submit the Corrected Field notebook, and that's what you'll do. Just take your notes and do the same thing that I have done, using this and the vodcast, which will be here as well. All right, so that's it, our little short lecture on how to adjust the elevation on a differential loop. The reason being that we know that the flagpole and the fire hydrant did not move, so we have to adjust our data to match the reality of the situation. So if you have any questions, please email me, and we will take care of it at that time. Thanks. Have a great day.